Hello, ECO311. Now we move on to Chapter 10, multicollinearity. It means what happens if the independent variables are correlated. Now the point is how strongly or how weakly these independent variables are correlated. And is the linear relationship strong, weak, or exact or inexact? Okay. So this is what Chapter 10 is all about. Imperfect collinearity or multicollinearity. Later, I'm going to talk about the difference between collinearity and multicollinearity, and also the difference between imperfect and perfect multicollinearity. And then you might wonder, would imperfect collinearity or multicollinearity more likely to happen in time series or cross-sectional data? The answer is both. It is possible in both cases. But next chapter, heteroskedasticity, chapter 11, I can tell you in advance that it is more likely to happen in cross-sectional data. And then chapter 12, autocorrelation, about the correlation of the error terms. It is more likely to happen in time series data. And then the last chapter will be the longest chapter, chapter 13, in connection with underfitting, overfitting. Okay, so let's start with chapter 10. And then for chapters 10, 11, and 12, there will be 4 topics. Definition, which means the nature. Consequences. If the problem happens, what will be the consequences on your regression? I can tell you that almost all the consequences are bad. It would ruin the reliability of your regression. Detection, then you are going to learn some statistical methods to detect the presence of the problem. And then remedies, how are you going to get rid of the problem? So let's start with the definition. Let's start with perfect. I just want to tell you that when it comes to the word perfect, perfect means exact linear relationship. And then imperfect means very strong, but the relationship has not reached the exact stage yet. Not that strong, but very strong. And then if we use the word collinearity, it means there is only one linear relationship between the explanatory variables. And then if we use the word multi-collinearity, multi means at least 2, or you can say more than one linear relationship between the explanatory variables. So for the definition part of chapter 10, you need to know all 4 of these definitions. Perfect collinearity means one exact linear relationship between the explanatory variables, meaning the correlation coefficient between these explanatory variables could be +1 or -1. Actually, there is one very nice exercise. I think it is the question 1 of your exercise. You have to complete a table to define the 4 concepts with examples. And I want you to make an effort to go through the answers, especially the examples. So for this one, the example would be, if I run a regression, marks explained by x2 study hours and x3 study minutes, I think there is an exact linear relationship between x2 and x3, because 1 hour stands for 60 minutes, 2 hours stands for 120 minutes, and so forth. So I can say study minutes x3 is exactly equal to 60 times the hours. In other words, x3 is exactly equals to 60 times x2. So if I include both study hours and study minutes in my regression, I'm going to get an error message on eViews that it is impossible to derive a regression output. So keep in mind, when it comes to the perfect case, you will not get a regression output. And then let's skip to the third one. Perfect multicollinearity means at least 2 exact linear relationship between explanatory variables. So look at this one. Property price is a function of number of rooms, number of bedrooms, number of other rooms, number of washroom, and number of toilets. And from this regression, and I can already notice 2 exact linear relationships between the explanatory variables. First of all, the total number of rooms is exactly equal to number of bedrooms plus the number of other rooms. So this is the first exact linear relationship. And then secondly, the number of washroom is exactly the same as number of toilets, assuming we're dealing with formal dwelling. Usually in each washroom, there should be 1 toilet. Since there are 2 exact linear relationships between the explanatory variables, so if I run the regression like that, I suffer the problem, perfect multicollinearity, meaning I would never get a regression output. And then let's go back to the second one, imperfect collinearity, meaning there is imperfect means strong, meaning there is 1 strong linear relationship between explanatory variables. So if I run this regression, marks explained by home study hours and library study hours, I think there is a strong positive relationship, linear relationship between the two variables, because those who usually study long hours in the library, you expect them to do the same at home. And then in this case, imperfect collinearity, you will get a regression output. So keep in mind, imperfect means strong linear relationship, and you can get a regression output, but the regression output would be full of problems. This is why later we will look at the bad consequences. And finally, imperfect multicollinearity means there is at least two strong linear relationships between explanatory variables. And again, because of the word imperfect, you will get a regression output but full of problems. So let's look at this regression. Marks explained by hours on campus, hours attending lectures, hours socializing, and the number of lectures. I can already say that there is a strong relationship between the first three variables because your total time spent on campus is more or less roughly approximately equal to, not exactly equal to, but the majority of the time you spend on campus consists of the hours spent attending lectures and your hours socializing. Okay, but I wouldn't say the relationship is exact because remember, you also spend a little bit of time on campus, maybe walking between the lecture venues, queuing at the tuck shop, and time spent in the washroom, seriously, and time looking for your car in the parking area. But at least I can say there is strong relationship that hours on campus is strongly related to, linearly related to the sum of hours at lectures and hours spent socializing. And then the second strong linear relationship is the hours you spend on campus is strongly positively correlated with the number of lectures, because the more lectures you have, then usually you would spend more hours on campus. So this is the second strong linear relationship between the explanatory variables. Okay, and then this one, why does it happen? This is optional for your personal knowledge enrichment purpose, so you can have a look, but I'm not going to ask question on that. Consequences, most of the consequences are bad except the first one. Your OLS estimators remain blue, then it means you can trust your parameters, despite the fact that imperfect collinearity or imperfect multicollinearity happens. Your parameters are still okay, more or less blue. But then the problem would now begin that the standard error of the parameters becomes larger. So keep in mind, larger. You need to remember the direction, larger. And since the standard error of the parameter becomes larger, then the confidence interval, just remember what you did in chapter 8 or in ECO311, think about the equation, confidence interval, the t involving the t statistic. So if your standard error of the parameter becomes larger, then you will have wider confidence interval. Okay, and then your computed t-stat will become insignificant because, do you still remember the equation for computed t-stat? It is your, let's say, B3 head minus the B3 star, the hypothesized value, divided by standard error of B3 head. And remember, because of imperfect collinearity, it causes the standard error of the parameter to become larger. So this is the whole equation for computed t-stat. So if your denominator becomes larger, then it would cause your computed t-stat to become smaller, or we can say insignificant. Okay, and then if your computed t-stat becomes insignificant, then you will derive unreliable hypothesis testing because it becomes more difficult to reject the new hypothesis. Again, refer back to what you learned in chapter 8 and ECO311. Okay, and refer to my detailed explanation in the study guide, actually. So if you look at the study guide, I think I provide very detailed explanation about the consequences. So after the table, it is here. Slide number 6, I provide very detailed explanation using some mathematical thinking. Okay, and then if you make some small changes to the data, then all of a sudden your regression parameters will change completely. Okay, and then the next one, R square is still okay, it is high, but then you have a lot of insignificant computed t-stats. Finally, you might get a wrong sign for the regression parameters that no longer conform to economic theory. Okay, and then you can go through this example. Then if I ask this type of question, I will give you two regressions. The first one is normal. The second one is abnormal, suffering imperfect collinearity or imperfect multicollinearity. So in this one, the first regression, consumption explained by price and real income, it makes sense. But the second one, consumption explained by price, real income, and the population 15 stands for the household members aged at least 15 or working age population. And it is argued that there is strong linear relationship between population 15 and real income. The reason is the more working age population members are present in the household, then we expect most of them to be working. Then that leads to higher real household income. In other words, there's a strong positive relationship between the two variables. So if I include population 15, it might ruin the regression. It causes imperfect collinearity to happen. Then from the two regressions, you can talk about the consequences. Don't you notice? The standard error of the parameter becomes larger. Look at the blue highlighted text. Standard error of B2 hat used to be 0.1492. Now it inflates to 0.1888. Similarly, standard error of B3 hat used to be 0.0002, but then in the second regression with imperfect collinearity happening, it increases to 0.0015. Okay, and then we can move on to the detection. 4 detection methods. High R squared, but insignificant t statistics. So let's go back to the last slide. We still have high R squared here, but do you notice with the presence of imperfect collinearity, 2 computed t stats become insignificant. Don't you notice the probability value exceeds 10%? So I'm done with the first one. Second one, there will be strong correlation coefficient between explanatory variables. Then you might wonder, where would I get the information on correlation coefficient? The answer is I must provide you a table. Okay, so it shows you the correlation coefficient between each pair of explanatory variables. So do you notice that the correlation coefficient between population 15 and real income is very strongly positively correlated, 0.9926. Very strong positive correlation. So I'm done with the second one. Third one. Okay, I have to run auxiliary regression. So this is my original regression, y explained by x2, x3, x4. But if I run auxiliary regression, so auxiliary regression means one explanatory variable regress on the other explanatory variable. So in this case, I can run 3 auxiliary regressions. So if the R squared from the auxiliary regression is greater than the R squared from the original regression, which is this one, then it implies the presence of imperfect collinearity or multicollinearity. And then I will provide you the information. So it is here. This is the R squared of the original regression, and then the R squared of each of the 3 auxiliary regression. Don't you notice that 2 out of the 3 auxiliary regressions, the R squared 0.9860, 0.9858 is greater than the R squared of the original overall regression. Okay, so I'm done with this one. And then the last one, VIF, variance inflation factor. You must remember the formula. It does not exist in the formula sheet. So it is 1 divided by bracket 1 minus R squared, but you must remember which R squared to substitute. The R squared must come from the auxiliary regression. And if VIF is greater than 10, then it implies the presence of imperfect collinearity or imperfect multicollinearity. So if I go back to this, you can, since we run 3 auxiliary regressions, so we have 3 R squared, and then we substitute each R squared into the equation 1 divided by bracket 1 minus R squared, then you are going to work out these 3 answers. So 2 out of the 3, VIF is greater than 10. Okay, so this is the 4th way to detect for the presence of imperfect collinearity. So I'm done with this. And then in the next video, I will talk about the remedies.